If you're looking for additional Regents exam info, then jump onto your computer and log on to regentsreviewny.net. It's the official website for the series, and it's loaded with test prep resources that are guaranteed to cure those Regents exam blues. Video clips, test-taking tips, exam schedules, and a host of links to other Regents resources. It's all here. And don't forget, all of the programs in the series will be available for streaming on the site once the television broadcast schedules are complete. So what are you waiting for? Increase your chances for a better score on test day. Regents Review 2.0, the next generation of Regents exam prep. Regents Review 2.0 is made possible by New York State Teacher Centers, providing professional development for teachers by teachers. New York State Teachers Centers, a source for teachers and a promise to students. And by NYSET, representing 600,000 professionals in education and healthcare. And by contributors to your PBS station from viewers like you.
Moving on to cluster emphasis 5. That asks us to understand solving equations as a process of reasoning and explain that reasoning. So here we're going to solve algebraically for all values of x. We have the square root of x minus 5 plus x equals 7. Well, we have a couple of different x's there, and you always need to get the most complicated piece alone first. So x minus 5 under a square root is the most complicated piece. So the first thing we want to do is subtract x from both sides. And we're left with the square root of x minus 5 equals 7 minus x. Now that the complicated parts alone will undo what's making it complicated, and what's making it complicated is the square root. We undo square rooting by squaring, so I'll square both sides. And I get x minus 5 equals 7 minus x all squared. I strongly suggest you write it out as 7 minus x multiplied by itself. That's what squaring means. A lot of students will just square the parts inside and you lose a part, and that won't give you a wrong answer. So always write that out to be safe. Okay, so we have x minus 5 equals 49. You're going to double distribute this. Some of you call that FOIL. Minus 7x plus x squared. We can combine like terms on the right. We have 49 minus 14x plus x squared. And now that I have squared terms, I need to set it equal to 0 to solve. So I'm going to subtract x and add 5 to both sides to make this my 0 side. So what I do to one side, I do to the other. I'm subtracting x and adding 5, combining like terms, and then I'm going to put it in a better order. So this is really x squared minus 15x plus 54. Okay, so I need to solve x squared minus 15x plus 54. We're back to factoring again. We've seen a lot of factoring today, and you'll see a lot of that on your test as well. It's a major skill you need to have mastered. So x squared minus 15x plus 54. We need two numbers that multiply to 54 and add up to 15. They will be 9 and 6. Now they need to add to a negative number and multiply to a positive, so they'll both have negative signs. So x minus 9 times x minus 6 will add to negative 15 and multiply to positive 54. Those are factors set equal to 0, so you set both of your factors equal to 0 and solve. If x minus 9 equals 0, then x equals 9. And if x minus 6 equals 0, then x equals 6. Now, one of the most important things you do anytime you solve an equation is check. Especially in Algebra 2, they'll give you extraneous roots a lot. You must check to make sure that everything is working. So you'll substitute them both back in. Let's start with 9. So my original equation is the square root of x minus 5 plus x equals 7. I'm going to check 9. So if I have the square root of 9 minus 5 plus 9, does that equal 7? Well, the square root of 9 minus 5, that's 4. The square root of 4 is 2. 2 plus 9 does not equal 7. You need to reject that answer of 9. It does not work. We often get extraneous roots when solving quadratics. When we substitute 6 back in, the square root, let's see, the square root of 6 minus 5 plus 6, does that equal 7? Well, 6 minus 5 is 1. The square root of 1 is 1. 1 plus 6 is 7. So x equals 6 works. We'll keep that answer. X equals 9 does not. Make sure you reject that. Very often you'll have to reject one or both answers. In multiple choice, I see that a lot. And students will get that multiple choice question wrong where there's no way of getting partial credit because they didn't take the time to go back and check. So please, if nothing else, always go back and check your work. Okay, moving on. This is a supporting problem for that same cluster. And I chose this question because this is a new topic for Algebra 2. We've always solved systems of 2 equations. Now we're expected to solve systems of 3 equations. The process is the same. Math is consistent, but it's a little bit more work. So here we go. We're going to solve the following system of equations algebraically for all values of x, y, and z. And we have those 3 equations. X plus 3y plus 5z equals 45. 6x minus 3y plus 2z equals negative 10. And negative 2x plus 3y plus 8z equals 72. Okay, well, we're going to solve these by elimination, just like we used to do in Algebra 1. And so you want to look for a perfect setup. You want something to cancel out really quickly so that you don't have to do any extra work. It's enough work as it is. And the first thing I notice when I look at the system is that all of my y's are either a positive 3 or a negative 3. That is a perfect setup for elimination. When I add equations, when the coefficients are the same and the signs are the opposite, they'll cancel right away. I suggest that you number your equations, 1, 2, and 3, to keep organized, because this is going to get messy. So, first things first, I'm going to look at equations 1 and 2 by themselves, because when I add them, those y's will cancel right out. So I'm going to rename or rewrite equations 1 and 2. I have x plus 3y plus 5z equals 45, and 6x minus 3y plus 2z equals negative 10. Those are equations 1 and 2. Again, you need to communicate your work to the person grading your test, so it's good to just be organized and label equations like that. When I add these, I'll get 7x, my y's cancel, that was my goal, plus 7z equals 35. Okay, so I've simplified those equations. Now if I look at equations 2 and 3, if I add those, the y's will cancel again. An important point is when you've decided which variable to eliminate, I chose y's. If I eliminate y's in my first set of problems, I need to eliminate the y's a second time. Otherwise, you'll get yourself into a mess. So I chose y's early on. I'm sticking to it. So I'm going to take equations 2 and 3 and do the same thing. I have 6x minus 3y plus 2z equals negative 10. And I have negative 2x plus 3y plus 8z equals 72. We'll add those together. 6x minus 2x is 4x. The y's cancel. 2z plus 8z is 10z. And negative 10 plus 72 is 62. Okay, now I have 2 equations with 2 variables. I'm back to Algebra 1. So I'm going to put those 2 equations together. 7x plus 7z equals 35. And 4x plus 10z equals 62. Okay, I need to eliminate again. I need to make a decision about which variable to eliminate. It really doesn't matter. You can choose x or choose z. Either one is going to be a lot of work. I need to make one of them positive, one of them negative, and the coefficients have to be the same. So because I like working with 10, I'm going to eliminate the z's. I can take my first equation and multiply it through by negative 10, because all that's really doing is changing signs and throwing on a 0. It does mean that I need to multiply my second equation through by 7. Again, the goal being to eliminate a variable. And by doing that, this coefficient will become negative 70. This will become positive 70. When I add, they'll be eliminated. Okay, so let's do the distributing. So when we distribute negative 10 through, we get negative 70x minus 70z equals negative 350. When I multiply 7 through the bottom, I get 28x plus 70z equals 14,434. Okay, we'll add those equations together. Negative 70 plus 28 is negative 42x. The z's cancel, and that is going to equal 84. Negative 350 plus 434 is 84. Divide both sides by negative 42, and x is negative 2. Okay, you're a third of the way done. Now that you've figured out what x is, you need to determine what z is, because you have two equations with just x and z in them. All right, it does not matter again which one. I kind of like littler numbers, so I'm going to go for the 7x plus 7z equals 35. Substitute negative 2 in for x, and we get 7 times negative 2, negative 14, plus 7z. Oops. Equals 35. Add 14 to both sides. 7z equals 49. Divide by 7. Z is 7. I have x, I have z. Now I can go back in and finally find my y. So take one of your original equations. I'm going to grab x plus 3y plus 5z equals 45. And I'm going to substitute my x equals negative 2 and z equals 7 into them. Just double check that you copied it right. X plus 3y plus 5z equals 45. Okay. So I think x is negative 2. I'm going to find y. 3y plus 5 times 7 equals 45. Clean that up. Combine like terms. Negative 2 plus 3y plus 35 equals 45. 3y plus 33 equals 45. Subtract 33. 3y equals 12. Divide by 3. Y equals 4. So finally, we have a solution to our 3 by 3 system. We have x equals negative 2, y equals 4, and z equals 7. X is negative 2, y equals 4, and z equals 7. That is our answer, but of course, you always want to check. So use your calculator, store those values, store negative 2 into x, 4 into y, and z into 7, 7 into z. Use your calculator, and when you store those, and then retype those 3 equations into your calculator, you will get true each time, and so that you know your answers to your system work. So a 3 by 3 system really isn't much different than a 2 by 2. You just have to eliminate 2 variables instead of just the one. Okay.
We're rolling.